Hello everyone, I would like to look at some interesting partial derivatives, and the reason that they're interesting is they hail back to the derivatives that you guys should already be accustomed to. Okay, so if I read this one out loud, it says 7x minus 9y to the fifth power, so that means we take 7x minus 9y times 7x minus 9y times 7x minus 9y. We do that 5 times. So clearly the 5 is the thing that we need to worry about the most. So when I take the derivative, I need to do the chain power rule. So the 5 comes down, 1 less power. Okay, there's step 1 and step 2. Bring the power down, 1 less power. If you remember from what we did before, you have to leave the inside alone. 7x minus 9y. That's my brick, as I call it. Okay, it is your unchanging piece. And then you finish off this derivative by allowing the brick to disintegrate and taking its derivative. Look closely. This says take the derivative paying attention to the x's. So the derivative of 7x is just 7 minus the derivative of 9y, which is 0. Right? Because there's no x in this particular term. Okay, so if you wanted to simplify this, then you can take this 5, which is to the first power, multiply it by the 7 that's to the first power, and get 35 times 7x minus 9y to the fourth power, and you'd be done. Okay, now something similar is going to happen when you take the derivative with respect to y, because you still have this chunk of information multiplied out 5 times. So bring the 5 down, 1 less power makes that a 4. This inside chunk has to stay the same. Why? Because you just did a derivative. Bring the power down, 1 less power. So this would be 7x minus 9y. Do not change the inside piece until you get out here. You're multiplying by the derivative of the inside with respect to y, right? So this first term, 7x, doesn't have a y in it, so its derivative is 0, minus the derivative of 9y is 9. Okay, so when you put those together, you get this 5 is to the 1, the negative 9 is also to the 1. This is to the fourth power, so I can't combine it with those two. So I get negative 45 times 7x minus 9y to the fourth power, like that. Okay, so let's look at the second problem. And you'll notice this, if I read this out loud, it'll be the natural log of this chunk of information. So I know how to take the derivative of the natural log. That's 1 over whatever happens after the natural log. So 4 plus 8x squared plus 11y squared just drops to the denominator, right? There we go, there's my brick. Okay, I didn't do anything to that other than drop it to the denominator times. Notice this is a chain rule, so that brick has to disintegrate. Derivative of 4, again, we're paying attention to the x's this time, is 0. There's no x there. Wait a minute, this has an x in it, so plus 16x. And then the 11y squared, no x, so plus 0. Okay, so I'm going to put this over 1 so that I can simplify. If you have the product of two terms, then it's multiply the numerators and then multiply the denominators. So in the numerator I get 16x, and in the denominator I get 4 plus 8x squared plus 11y squared. All right, so let me try to separate my work because I don't want to. Okay, so now let's take the derivative with respect to y. It's still a natural log, so the start is 1 over 4 plus 8x squared plus 11y squared times the derivative of what we just dropped to the denominator. Notice we took this chunk of information, we didn't change it, we just dropped it to the denominator in both of these derivatives. So you're multiplying by the derivative of this, paying attention to the y's. So the first one's going to be 0, there's no y in that. This one also doesn't have a y in it, so plus 0 plus the derivative of this last one is 22y squared. Okay, you can put this over 1 and then simplify it from there. So in essence, your final answer would be 22y squared, because that's 1 times that, over 4 plus 8x squared plus 11y squared, because that's what the product of these two numbers is. All right, let's go to problem number 3. All right, This is 5 times e raised to a power. Notice this is an exponential function because it's e to some variables. So when I take the derivative with respect to x, I'm going to pull out the 5, right? The 5 is just a constant. And so now I can focus on taking the derivative of the variable part. Okay, here we go. What's the rule on exponential? Cop e. E to the y minus 2x. Okay, there's the copy part. Cop e times the derivative of the power, right? So that's how we finish off all chain rules. So we gotta be paying attention. Your derivative is with respect to x. So the derivative of the y is 0. There's no x there. And the derivative of the negative 2x, negative 2. Okay? So let's find the derivative with respect to y. Still pull the 5 out. And the step 1 is just to copy down what you started off with. Let me put a bracket there. E to the y minus 2x. There's the copy part. And now we want to disintegrate that power by multiplying by the derivative of it. The derivative of y is 1. And the derivative of negative 2x, notice it doesn't have a y in it, so that's 0. Okay? And you're done. All right, let's keep going. Okay, let's look at problem number 4. Okay, so if we look closely, we see this is x squared times e to the 3xy, right? So this is a product rule. Okay, so with the product rule, you remember this is the one I said it was like 2 kids playing Monopoly. One of them takes a turn while the other one watches, and then they flip-flop, right? So I'm going to take the derivative of x squared with respect to x. So let's see. This has an x in it, so 2x. So this one just took a turn, right? And I'm going to leave this one alone. E to the 3xy. No derivative there. Plus, now we leave the x squared alone. It's going to sit back and watch while the other one takes the turn. All right? So the rule on the exponential, copy e to the 3xy times the derivative of this power. Let's see. Notice this has an xy combination, so I'm going to pull out the 3 and the y, and then the derivative of the x that's left over is 1. Please see that last video if you don't understand what I did. I'm going to zoom in on that so that you can see it. Okay, so when I took the derivative of the power, notice this has an xy combination. So I'm pulling out the 3, which is constant, and the y, which is constant. Why is the y constant? Look, x is your changing variable, so y has to be constant. And the derivative of this x that's left over is 1. Okay? So let me take the derivative with respect to y. Okay, so I'm going to take the derivative of this x squared, but look, I said y was my changing variable. So when I take the derivative of x squared, that's 0. There's no y there. Now I'm going to leave the e to the 3xy alone. Plus, now the x squared sits back and watches while you take the derivative of this e term. So let's see. Look closely. The y is changing. This says 3xy, right? So the first step is just to copy it down, e to 3xy. And then this derivative of this power, if the y is changing, both the 3 and the x has to be constant, and the derivative of this y that's left over is 1. Okay, this does take some practice, so clearly this is going to be 0. 0 times anything is 0, so your answer should just be what you have there. Last one amongst the interesting one, and this says find the derivative of z paying attention to the x's. Now you have an x in the numerator and you got an x in the denominator. So what your best bet is going to be the quotient rule. So what's the quotient rule? Low d high minus the high d low all over the low squared. Okay, so if you don't remember these rules, please go back and refresh your memory. So low is the denominator, x minus 9y. Derivative of the high, you got to be careful. It says take a derivative. You want the x's, and this has an x in it, so 3x squared minus the high, which is x cubed. Now this says take the derivative of the low, but you only pay attention to the x's. So this is 1 minus 0, or just 1. And in the denominator you have x minus 9y, the quantity squared. Okay, please practice these in your homework.